STEM couples energy storage with artificial intelligence so that its customers can store renewable energy on a major scale. Then they can use it efficiently when and where they need it, saving time and money.
We build and operate the largest digitally connected network of intelligent energy storage solutions that's all cloud-enabled and is driven by our AI software platform that we call Athena. STEM's AI-powered energy storage solution gives businesses flexibility and control over their energy spend. We lower cost by storing electricity when it's affordable and using it later when costs are high.
As well as responding to increased customer demand for clean energy, STEM aims to create a cleaner, efficient, and more modern grid. Its products are designed to assess the grid's local capacity and send energy when it's needed, rapidly.
What we do with storage is we help that customer behavior, that customer need, get matched with that available energy supply by using the battery and the AI to predict both the availability of energy as well as the customer need, and then using the battery effectively to shift those into a balanced mode.
The company is currently contracted to build 1,000 systems, which amounts to over 380 megawatt hours of energy storage services in the US and internationally.
Costs continue to come down, scale continues to go up. The costs are driven by scale in solar and wind, and we expect to see that continue to grow. All the value that storage can provide those two solutions that will actually help those industries grow and unlock various value streams that we can apply with our Athena platform into those services and actually lever up the returns for the wind and solar developers going forward.
So going forward, artificial intelligence may well be the brains behind the beauty of vast quantities of clean energy stored safely, at the ready to cope with the peaks and troughs of energy demand.
For centuries, humans have struggled to understand the weather. From putting a wet finger to the wind, listening to cricket chirps, and looking to the stars for answers. Now we believe AI can help us advance and understand how we can predict it. Meet MetNet3 and GraphCast, our deep learning models designed to generate more accurate weather forecasts. Traditional methods work by simulating entire systems, with hundreds of variables interacting. In practice, this means abstracting those variables into equations and then manually coding them into algorithms. Our AI models take a different approach. They analyse past weather data to learn cause and effect relationships between weather conditions. These learnings allow the models to find subtle trends and patterns inside the data, which they extrapolate to predict what could be coming. MetNet3 and GraphCast outperform the best systems in the world, seeing further into the future more accurately, efficiently, faster, and in better detail. For everyday and even extreme weather, MetNet3 is already improving the accuracy of 24-hour weather forecasts on Google Search.
We're living through one of the biggest foundational industry transformations that you could ever imagine. Decarbonization is mission critical for the planet. 90% of the world's power transmission utilities are equipped with our technology. The grid is the most complex man-made machine ever built. As the grid has been constructed over the past 100+ years, intermittent generation was never a consideration. The grid just wasn't constructed with that in mind.
Renewables generation is really, it's bidirectional power flow. So you're generating power in different spots that you're not used to, whether that be in the distribution network or in the transmission network.
We don't have enough renewable capacity today to meet the demand that we have for electricity. In addition, renewables work on fuel sources that are intermittent. The sun doesn't always shine, the wind doesn't always blow, but generally customers always want electricity. We are learning more about how to operate gas power plants more efficiently to reduce emissions, to improve fuel utilization, and to improve flexibility so that they can be used in a more intermittent fashion to support energy demand when renewables can't.
Well, I think the role of industrial software is really to respond to the great dynamic changes that are happening, whether it be changes in the weather or the customer demands or the actual sources of energy you have on the system. Digital technologies are vital for the energy transition, and it all comes down to the data. When I think about the energy transition, I think about two great technologies that we bring to bear. One is digital twins. We use digital twins, which are learning, living models of an asset to model entire networks and help power utilities reduce cost. Industrial AI is where we're taking AI capabilities and applying it to the industrial data you have. By leveraging utility data and harnessing the power of domain knowledge combined with industrial AI, customers can change their workflows and processes to become more innovative and profitable.
One-third of the world's electricity is created by GE, and 40% of the electricity that's produced on the planet is touched in some way by our software. GE Digital is driving digitization of the power sector in partnership with some of the world's largest utilities and power producers. And so to be a part of that mission, to be right in the middle of that, is incredibly exciting.